Chapter 6, Force and Motion 2. So this entire chapter is again dedicated to Newton's laws of motion and the application to problem solving with them. The problems in this chapter tend to be a little more challenging, have more multiple parts to them, so you'll notice that the notes packet is much shorter than our other packets, and the homework packet is longer than our other packets because it's really about practicing your analysis and your problem-solving techniques for those more challenging problems. So the first thing we're going to go back and revisit now is the frictional force. So in terms of what we have here, the first thing you absolutely need to do is not have to rely on an equation sheet or anything other than your knowledge of friction to know that the frictional force, by definition, is given by the coefficient of friction. Again, that's the Greek letter mu, mu, times the force normal. And over here, and I have in bright pink screaming at you that do not lapse into thinking that the force normal is always equal to the weight force mg. So sometimes, as if we peek down here, the weight force, 58.8 newtons, does equal the normal force. But we talked about in Chapter 5 when the normal force can be greater than mg, and that's if you have additional forces pushing down. It can be less than mg if you have additional forces pulling up. And of course we have the normal force inside of elevators where, depending on whether the acceleration of the elevator and by extension the person inside the elevator is positive or negative, the floor is either pushing the person up, in which case we get a positive acceleration, and the force normal would be greater when we bring the mg over, and we have the acceleration negative when the floor is falling away from the person's feet and there's less of a normal force. So at any rate, in elevators we always use force normal minus mg equals ma, where the acceleration is the acceleration for the elevator, and again by extension the person in the elevator, and that plus or minus comes from whatever the elevator is doing. So we're going to look at this in more detail in this unit, not elevators, but the force normal and the frictional force. And if you can see what happens in this example we have, you're just told you have a 6 kilogram object, and again you have to know that a 6 kilogram object is mass. Here they tell you it's m, but in questions they will not always tell you that 6 kilograms corresponds to mass, because there's a big difference between a 6 kilogram object and a 6 Newton object. Of course, Newton is the weight then in that case, and that would be mg. As we said in our last unit on friction, the coefficient of friction has two considerations, two values. The first value is the static frictional coefficient, and the second is the kinetic coefficient. And the static coefficient is always bigger than the kinetic because that's the break loose friction. That's what it takes to break the object loose. So when we have a coefficient of friction between two objects, like let's say we have a wooden block and, I don't care, a tile floor. So we have a wooden block and a tile floor, and they're rough surfaces, so this wooden block and the tiled floor have some coefficient of friction between them. If we need to push the box to break it loose from the surface, then we're going to push to the right, or pull to the right, and break it loose. Well, how much force do you need to break it loose? Well, you need whatever amount of force is just above the frictional force that you will calculate when you use the frictional force is mu static times the force normal. So if the 35 newtons is anything, and I mean anything, bigger than mu static times force normal, this box breaks loose. In this case, we are told that the static coefficient and the kinetic coefficient are actually the same value. So that is not normally the case. It was just for simplicity in this example that was chosen. And it's at 0.7. So normally when you break the box loose, the coefficient of friction does reduce slightly. It might go from 0.7 to 0.6. So, but in this case, we're just going to use the 0.7. We were given our 6 kilogram mass, and we can see then that we have a 58 Newton box, a 58.8 Newton normal force. And when we do the coefficient of friction times the force normal, we get 41.16 newtons. So we have a static frictional force of 41.16, and we are pushing with 35 newtons. Okay. You have to be careful about just putting your head down and plowing forward, because if you put your head down and plow forward, you are going to get the correctly calculated but incorrect result that the frictional force is going to pull the object backwards with an acceleration of negative 1.0027, which that is wrong because friction would never do that. Static friction won't do that. You're pushing with 35 in this case will simply mean that the box will not break loose. And what you have in this problem is what I have circled over here, so please make sure you get all of these annotations in your notes. So the frictional force is the maximum available, which is the force you need to move the box, and therefore the actual frictional force in this problem is actually 35 newtons because we know the box isn't moving. To move the box, you would need a pulling force of anything bigger than 41.16. So 41.160000000001, that would move the box. Okay? So what is the frictional force? If you are asked a quiz, a test, a homework question, the frictional force is 35. The max available frictional force, 41.16. But if they ask you in a problem, what is the frictional force? They are asking you for the actual frictional force. So you can see, even from this discussion, there's going to be a lot more going on in individual problems, and that is why you are going to have more homework questions to look at. And on the next page of notes, we simply have another example of friction with kinetic friction and static friction. So that is it for our intro lesson to Chapter 6. Hopefully everything made sense relative to what we've talked about with friction from our last chapter. Let me just one last time emphasize the importance of memorizing and knowing always friction is mu times the force normal. So there you have it.